Hello, everyone, and welcome to this 2024 MIT Integration B exam. This is a calculus exam whereby you are given 2 minutes to work out this integral. This is integral that runs from 1 to 2024 of the logarithm of x to base 43, floor of it. So you are looking at the floor of the logarithm of x to base 43 dx. So the function here f of x is the floor of the logarithm of x to base 43. So this is the function we have to deal with. Just a reminder, what is the floor of x? The floor is a function that calculates the integer parts of any expression. For example, the floor of 4.3 is 4. The floor of 5.7 is 5. It says it calculates the nearest integer. So the nearest integer to this, because you know that on the number line, we have to pass 4 before we get to 4.3. So it's calculating the closest integer to a particular number. On the number line, we have to find 5 before we get to 5.7. So the floor of 4.3 and the floor of 5.7 is 5. So now we are asking you to find the integral of f of x. So f of x is the floor of logarithm of x to base 43. And obviously, let's study this function. F of x equals to logarithm of x to base 43. Now, notice that here, this function takes, this integral ranges from 1 to 2024. But notice that this function here, f of 2, f of 3, f of 5, f of 6, they are all equal to 0, because f of 2, for example, is equal to the floor of logarithm of 2 to base 43, and this will be 0, because this is a number less than 1. So the only number closer to 1 is 0. So 0, you get to pass 0, then you get to 1. So since these numbers are like 0.5, 0.7, 0.9, they are all less than 1. So the closest number to these numbers will be 0. So all of this, the floor of the logarithm of 3 to base 43 would be 0. So this means one thing. This means that given this interval, we are calculating it. And now, notice that definite integral is asking you for the area under this graph. So we're going to try to sketch this graph. Let me take out this part of the board. So this on our coordinate axis, let's see, on our coordinate axis, okay, notice here that notice one thing, that this graph, this is 0, but the graph starts at 1, the function starts at 1, so the integral starts at 1. So notice that from 1 up until 43, this function is 0 all through. So because from logarithm of 1 to base 43, logarithm of base 2 to 43, logarithm of 3 to 43, they are all equals to 0, because you are taking the floor, like we're taking the floor of all these numbers, and they are all equal to 0, because I told that they are numbers less than 1. So the closest number to 1 will be 0. So we probably get like 0.4, 0.7. So I'm sure if you plug this in a calculator, you're going to get a number less than 1. So the closest number to 43 there, like the closest number to 1 is 0. So that's why the floor would be, this function would just be flat until we get to 40. Now, if we get to 43, then f of 43, for example, f of 43 would be the floor of the logarithm of 43 to base 43, which is basically 1. So if we get to 43, we end up with 1. So this is 1 here. Now, this is going to continue this way until we get to 43 square. So this is going to continue this way until we get to 43 square should be what? Let's say 43 times 43, that would be 9, 12. So 12 here, that would be 12 to 1 of 16 to 16 plus 9 is 17. That is 17. That was 1849. So until we get to 1849, this function will be 1 or 2, because like f of 45, the logarithm of 45 to base 43. That is the floor of this logarithm is going to be 1 point something, probably a decimal. Let me say 1.2, not 1.2, like 1 point something here. Then it's going to be a number less than 1. So the closest number to 1.5 is 1. So this function is going to be 1 all throughout this range. So this function is going to be 1 all throughout until we get to 1849, where it suddenly jumps to 2. So if we get to 1849, this is 1, it's going to jump to 2. So it's going to jump to 2. And then it's going to maintain this run until we get to, let's say 2024. Let's try to take 43 cubed. Let's try to see this number. Let's try to find 43 cubed. So that would be 1849 multiplied by 43. That would be 27, 2, then 12 plus 2, 14. So you take 4 and you keep 1. So 4 times 3, that would be 16 plus 24 plus 1 is 25. So 5, you get to keep 2. Then 3 times 1, that is 3, that is 5 here. So you see, we're going to end up with a number more than we're going to end up with a number more than 2024. So we only have to consider the case whereby the function, like this function, stops at a point 2024 here. So it's going to still be 2 until we get to 2024, somewhere around this. So this is the shape of this function. Now we're going to find the area here of this graph. Now the area before this is 0. So this area here is 0. The area of this rectangle here is 1849 minus 43 times 1, because 1 is the height. While the area of this bigger rectangle will be 2024 minus 1849 times 2. So the area of this integral that runs from 1 to 2024 of the floor of log x to be 43 dx, this integral alone would be 1849 minus 43. That would be, let me see, 1849 minus 43, that would be 60. So 1806. So this is 1806 plus, now 2024 minus 1849 times 2. So if you subtract 2024 from 1849, so you have 2024 from 1849, you get 14 minus 9, that would be 5. So you get 5. Then you have 10 here, and then 11 here minus 4, that would be 7. Then 9 minus 8, that would be 1. So 175. So that is the 175. Let's see what our answer. Okay, well, I have to multiply that by 2 as well. So 175 multiplied by 2, because I have to multiply the result by 2. Then we get 10, 0 to 1, 14 plus 1, 15, 5. Take 1, so plus 1, that would, 2 times 1, 2 plus 1, that is 350. 2 plus 350. So we get 1806, then 350, we get 6, 5. 8 plus 3 is 11, right? Yes, 11. So you get 2156. So basically this is equal to 2156. So this integral calculates the area. This integral calculates the area of this function. There's the area under this curve. So it calculates all this area here. And like I said, this function alone, this floor, let me take up some space. Everything here is getting messy. So please bear with me. Already now, the floor of this function here, which measures the floor of x to base 43 here, is 0, because if s gets the value 1 up until 42, it will be a number less than 0. So the graph will be flat. Then once s gets to 43, s jumps to 1. So not x, like the function jumps to 1, and then the function becomes 1 until you get to 1849. This 1849 is where is the value of 49 43 square, because the logarithm of 43 square over 43 would be 2. So it becomes 2 as you get to 1849, but it maintains this value upon it until it stops at 2024. It does not change value because the only way it can change value is when it becomes 3, because that's a jump. That's why this is called a step function, because this is the first step, second step, third step. So the only way it can change value is when it jumps to 3, and the only way it can jump to 3 is when we are dealing with a logarithm of 43 cubed to base 43. But in this case here now, 43 cubed is a value of x that is somewhere around here. It's outside our integration. Our integration stops at 24. No, 2024. So we stop here and just take the area of this function within this interval. So that will be all for today. And thank you for your time following up. Please, if you need any math tutorial, please do reach out to me and I can help you with your college courses. Thank you very much and have a nice day. Bye.